We're going to be looking today at dividing polynomials. We want you to be able to divide a polynomial by a polynomial of equal or lower degree using either long or synthetic division. If you are dividing a polynomial by a monomial, mono means one. So if you're dividing by one term, what we look to do is divide each term in the polynomial by the monomial. Okay, example 1 on your sheet would be dividing by a monomial. There's only one term on the bottom. There's no plus or minuses, meaning multiple terms. So when you do that, what we do is exactly what it says. We're going to divide each of the three terms up here by the term on the bottom. So what this problem is going to turn into 4x cubed, and we're going to divide that by our 4x plus our next term 8x, also divided by 4x, minus the 12x squared, again divided by 4x. It just means they're all being divided by that same term. Now we just go through and simplify each one of these and we have the answer. So on the first one, 4 divided by 4 is going to be 1. X cubed divided by 1x. Remember, when we're dividing with exponents, we subtract. So if we subtract this, 1, 3 minus 1 is 2. So that would end up being just x squared. On our next one, 8 divided by 4 is 2. X's cancel out. There's no x's left, so it's just plus 2. On our last one, minus 12 divided by 4 would be 3. And then x squared and x to the first, if we subtract those, that's 1x. So that would be our answer here. Now, a lot of times if this was like an ACT question, they would probably write this in descending order of degrees of x, so it would probably look like that in the multiple choice answers. All right, let's try another one of these. Number 2, they want us to solve this one. So again, each term here, we want to divide by the monomial term. So here, everything is going to get divided out by this 8, a to the 4th, b to the 3rd power. So if we divide the first one, 16 divided by 8 is going to be 2. a to the 5th power divided by a to the 4th power, we want to subtract those. That's going to be 1a there. 1a. And then b to the 3rd and b to the 3rd, those are going to cancel out. There won't be any b's left there. All right, plus, now we're going to do the same thing with this next middle term. 12 divided by 8. Now, 8 doesn't go into 12. So what we want to do here is figure out what's the number that would go into both. 4. 4 goes into 8 2 times. 4 goes into 12 3 times. So then we're going to list this as 3 over 2. Okay, 3 halves. All right, now we do the same thing with the a's and the b's. 4 on the bottom, 3 on the top. That means there's going to be 1 left here, so 1a left on the bottom. Here we can cancel out 3 of them, meaning there's going to be 1 left on the top. Okay, finally we do it the last one now. So the last one we also do it the same denominator. Again, 8 doesn't go into 20, but 4 goes in each. 4 goes in here 2 times. 4 goes in here 5 times. So this is going to be 5 over 2. With our a's, we got 1 on top, 4 on bottom. It means there's going to be 3 left on bottom here. And b's, we got 3 on bottom, 5 on top. That means there's going to be 2 left on top. There would be the answer to the problem right there. Okay, why don't you pause the video, try out number 3 and see how you do. All right, if you did number 3 right, you should have ended up with 3xy left when you divide the first one by the denominator. 5 is the only thing left when you divide the second one, because your variables are exactly the same here. And then when you divide the last one, you're going to get a 4. X's cancel out here. The 1x cancels out, and there'd be 1y left. So that should have been the answer you received there. So monomial ones are pretty easy. I don't think you should have any problem with those. The tougher ones are going to be when you end up with a binomial, or 2 things that you're going to be dividing by. So there's one of 2 ways you can do that. long division or synthetic division. Long division is similar to what you did back in elementary school when you learned how to divide, and that involves doing some longer hand notation. So let's do one with an example with a number first, and then we'll kind of walk you through what you would do with something. So let's say you wanted to take 42 divided by 5. Let's go something. Let's go 62 divided by 5. Okay, so if you were doing this problem, you would want to see first how many times does 5 go into 6. Well, 5 goes into 6 one time, so you'd write a 1 up there. Then the next thing you did was you took this 1 and this 5 and you times it back together and got a 5 here, and you wrote it there. Then we wanted to see what was left over, so you subtracted those and got a 1. Then the next thing you did is brought down the next number and repeated the process. So then you said, well, how many times does 5 go into 12? 5 goes into 12 2 times. So you would, or sorry. So we'd write a 2 up here because it goes in twice. We repeat. Now we want to take 2 times 5 and we get 10. We subtract that and get 2. And now that we have no more numbers left over here, that was our remainder. And so your answer would be 12. And for a while, then you just wrote 12 remainder 2. And then later on, after doing that for a while, your math teacher told you, well, that's really a fractional part. So it would be 2 over what you were dividing by 5, so the answer would be 12 into fifths. Okay, so that was the long division you had done back in elementary school. Same thing when you're doing these. This long division, you can do it the same process with these variables. So you want to set it up as a division problem. We're going to take z squared plus 2z minus 24 divided by z minus 4. So same process. First thing you're going to do is see how many times does z go into z squared. And if we divided those, z squared minus z would be 1z. Okay, so then the next thing, you'd take that and multiply it back to both of these things. And if you take z times z, you get z squared. If you take z times negative 4, you get negative 4z. Now, the next thing was to subtract. What do we get if we subtract this? Well, z squared, this z squared minus this z squared is going to equal 0. There's not going to be anything left over. They would, in essence, cancel out, equal 0. Now we want to do the next two things. What is 2z subtract negative 4z? Okay, so if we have 2z minus a negative 4z, that's turning into actually adding, so we'd end up with 6z. The next thing in the process of these problems was to bring down the next term and then repeat. So now we're going to do the same thing. What is z divided, or sorry, what is 6z divided by z? That would be just 6. The z's would cancel out. So then we'd write minus 6, or sorry, plus 6 because it's positive. Now multiply the 6 back to both of these. So if we multiply 6 back, 6 times z is 6z. 6 times negative 4 is negative 24. Now we want to subtract. What do we get when we subtract these? 6z minus 6z is 0. Negative 24 minus a negative 24 is also 0. Those canceled out, leaving 0, and that would be our remainder. This one divides in perfectly. There is no remainder. So our answer would end up being z plus 6 is the answer to this problem. That's long division. If you like that way, continue to use it. It works, nothing wrong with it. Most students like this second way of doing it called synthetic division. And this is another option for you if you maybe didn't, that long division way didn't click with you. To do long division, we actually take the division problem and turn it into a multiplying problem. And we do that by taking the divisor, what we're dividing over here, setting it equal to 0 and solving. So if we set this equal to 0 and solve, our z is 4. So we're going to take that little 4 and kind of box it to let us know that that's our multiplier. Then we want to take all these coefficients. Coefficients mean the numbers in front of all the z's up here. So our coefficient here is 1, our coefficient here is 2, and our last coefficient is negative 24. The process of synthetic division then, like we said, is going to turn into multiplication. We're going to drop this first number down as a 1. And then we're going to take our multiplier and times it. So we're going to multiply the 4 with the 1, and we're going to write the result, the product, right in the next column there. So 4 times 1 is 4. Now we're going to add up these two column numbers. 2 plus 4 is 6. Now we do that same process. Take our 4 here, times it, write it in the next column over. 4 times 6 is 24. Add the columns up. So negative 24 plus 24 is 0. This 0 here is similar to the 0 we got down here. That's the remainder that we got. There is no remainder. The 1 and 6 are the coefficients of our problem. Now you notice there's no variables with it, so you got to add put the variables back in once you're finished here. Now you got to know what variables to put it in. If we were taking z squared initially and dividing by z, z squared divided by z means when we're all done, our new biggest power is going to be a 1z, because that's what you get if you took z squared divided by z. So the first one should have a z, so 1z plus, and then we go down a degree. Okay, so if our first one's 1, that means our second one's going to be z to the 0 power. Well, when writing this out, you don't need a lot of this stuff. If anything's power 0, we don't need to write that. That's just going to be 1 or not there. Also, when you're writing stuff, remember, you don't need an exponent of 1. You also don't need to write coefficients of 1. And so the answer we get here is z plus 6. Same answer we got over here. So synthetic division can get you to that same solution. Notice a lot of these numbers ended up over here in synthetic division that we got over on the other side. Remember when we got 6? There's that same 6 there. There we were doing some like adding of 2 and 4 here. Here's that kind of that 2 and 4 that we had. And then when we were all done, we ended up with that remainder 0. Same thing here. So a lot of this stuff ends up being the same. It's just instead of dividing and subtracting, you're multiplying and adding. So that's what synthetic division does. So we're going to look at taking and doing some synthetic division or long division with these problems on your notes to kind of go through and do that. Let's look at number 4. Number 4 wants us to divide out this polynomial by x plus 4. When doing a problem like this, you want to identify what is the division going to be. So if you were doing this as a long division problem, you'd put x plus 4 out here, and then inside you'd put your numbers here. Now, if you were doing this, you would run into a problem very quickly, because when dividing this, 2x cubed divided by an x would be 2x squared. You'd multiply it back. You'd get 2x cubed. Now when you multiply it to this one, you'd get 8x squared. And remember, the next thing you know is to subtract. So these would cancel out. But can we subtract these? No, those are not like terms. So you run into a problem really quickly because you don't have like terms available. So when doing these problems, whether you're doing it synthetic division or long division, you need to make sure all the powers of 0 are accounted for, or all the powers of x. So see how this is degree 3? Now it's degree 1, degree 0. We skipped over degree 2. There is no degree 2 in there. Okay, degree 2 is missing. So when you're writing this out, if it's a long division problem, you need to write it out as 2x cubed plus, since we don't have a degree 2, 0x squared. You just have to put a filler in there of 0x squared plus the rest of it. Otherwise, it's not going to work out when you start doing it. Same thing if you do synthetic division. Okay, if we're going to set this up as a synthetic division problem, our first step would be to take our x plus 4 here, our divisor, put equals 0 and solve. It'd be negative 4. So that's our multiplier. Now we got to write in all the coefficients. 2, 6, 152. But if we just wrote those, we'd get it wrong. Same as with long division, you got to put a 0 in here for the missing degree of x squared, or it won't work. So you always have to fill in any missing one with a 0. Okay, if we continue this problem now, we should be able to get the answer. Drop down the first number of 2. Now we're going to multiply. Negative 4 times 2 is negative 8. Add the columns. 0 plus negative 8 is negative 8. Multiply again. Negative 4 times negative 8 is 32. Add the column up. Multiply again. Negative 4 times 38 is negative 152. And we get a remainder 0. So now we just have to write this back as a polynomial. So we need to add the x's back in. We are taking an x cubed and dividing by an x, meaning our biggest one here should be a x squared. And then you just keep dropping it down each time until you hit your constant term. That would be the answer to this problem. All right, let's look at another one here. Number 5. Okay, let's check. Do we have all our degrees here? Degree 3, degree 2, degree 1, degree 0. Yeah, here we got them all. So we're good to go in that respect. All right, but this one's a little different if we're going to do synthetic division, because now all of a sudden we end up with a number here. We haven't had that yet. If there's a number in front of your divisor, like in this case the 2, we need to get rid of that. So your first step is to go through and divide everything by that number. So we want this to be a 1. So if we divide the 2 there, that means everything in this whole problem we got to start by dividing by 2. Okay, so everything is going to get divided, which means our coefficients are going to end up being 2 divided by 2 is 1. This one's going to be 5 halves. This one's going to be negative 1. This is going to be negative 15 halves. We also got to figure out what's our multiplier. What's our multiplier over here? Well, now these 2's cancel out, so we got x minus 3 halves equals 0. If we add that over, that means our multiplier is positive 3 halves. That's our multiplier. So now we'll just do the same process and we get the answer. Drop the first number down to the answer, 1. Do some multiplying. 3 halves times 1 is 3 halves. Now add these up. Remember, when you're adding, you want common denominator. We have common denominator. 5 halves plus 3 halves is 8 halves. And 8 halves is the same as 4. So this is really going to end up being 4 here. Okay, let's keep going. So now if that's a 4, we want to do what's 4 times 3 halves, because we take this number and times it to what's ever here. So 3 halves times 4 is going to be what? You can use your calculator, otherwise you can just do some simple math again. You should know how to deal with fractions and whole numbers. 3 halves times 4, we can make this into a fraction as well by putting it over 1. When you multiply fractions, multiply across the bottom and across the top. So you get 12 halves, which 12 halves is going to be, 12 halves is going to be the same as 12 divided by 2 is 6. So you put a 6 there. Negative 1 plus 6 is 5. Okay, again, do some multiplying. 5 times 3 halves is going to give you 15 halves. Add these up, we get another remainder 0. So our three coefficients here are 1, 4, and 5. Put the variables back with it, and you got it. It would be x squared plus 4x plus 5. There's the answer. All right, go to the back. Let's try a couple more here. Number 6. They want us to divide this one out. Why don't you pause the video and try this one and see what you get. All right, let's see how you did here. Let's look at the degrees first. Do we have every degree? The first one's 4, 2, 1, 0. Nope, there is a missing degree of 3 in here. So when we're listing out our coefficients, we need a 0 in here. So make sure you did that. Also notice there is a number in front of our x here. So when that happens, we got to divide through everything by that. So you got to divide everything here by 2's, giving you these coefficients. Also here, 2 divided by 2 is going to be 1. So now you got x minus 3 halves equals 0. Looks like our multiplier is positive 3 halves over here. So if you went through now and did this right, you'd get 2. 2 times 3 halves is 3. Adding this up, that would be 3. 3 times 3 halves is 9 halves. Adding negative 17 halves and 9 halves should give you negative 8 halves, which is the same as negative 4. If you have trouble with that, use your calculator to help you. Multiply again. You're going to get negative 12 halves, which is the same as negative 6. Add them up, you get 1. 1 times 3 halves is 3 halves. Add that up. Looks like we get remainder 0. So answer here, now you got to plug the x's back with them. We were doing x to the 4th divided by an x. X to the 4th over x is x cubed, should be our biggest one. So we want a 2x cubed plus 3x squared minus 4x plus 1 would be the answer. So hopefully you ended up getting the same thing. All right, one last one here. Our last one, we're going to look at what happens if you get a remainder. We haven't had a remainder yet. So on this one, it looks like we do have all the degrees of x. We need to divide everything by 3 though, because there was a 3 there. So if we divide everything out, our coefficients are going to be 2, 5/3, negative 2/3, and 1/3. And our multiplier then, these cancel out, so we got x plus 1/3 equals 0, meaning negative 1/3 is our multiplier. All right, so do the same process. Drop it down 2. 2 times negative 1/3 would be negative 2/3. Add that up. 5 plus negative 2 would be 3 3/3 or 1. Multiply again. Would be negative 1/3. Negative 2/3 and negative 1/3 would be negative 3/3. Negative 3/3 is negative 1. Multiply again. Negative 1/3 times negative 1 is positive 1/3. Adding that up, we get 2/3. We ended up with a remainder this time. Okay, so the one part of this is going to remain the same. You want to add our x's back here, so you're going to get 2x squared plus 1x minus 1. But now we need to write the remainder. If you get a remainder, you need to first multiply it by whatever we had divided by up here. So remember how we had divided by 3? If we get a remainder, we actually have to multiply back through by that number. So 2/3 times 3 means we get 2. So we get a remainder 2. Okay, so we want to put plus 2. And remember, it's a fraction. Just like we got here, remember when we had remainder 2, we wrote it as 2/5 here because we are dividing by that. We need to write our remainder over what we're dividing by. What we're dividing by was 3x plus 1. So 2 over 3x plus 1. There's our answer. So when you get a remainder, it goes over what you're dividing by. So that's how you deal with remainders if you end up getting them. All right, last one here, number 8, says the area of a rectangle is shown. The length is this. What is the width? Well, think back to rectangles. You guys know a bunch about rectangles. If you got a length and width, that's what the area is, length times width. So if they want us to find the width using the area and the length, it would be, we'd want to divide by the length. The width would be the area divided by the length. So we want to take our area this divided by this. It's just one of those problems we've been doing. We have 3x squared minus 19x plus 20 divided by 3x minus 4. We can do this now with long division or synthetic division. Looks like since we have a thing here, we want to divide all these by 3. Okay, so our coefficients are going to be 1, negative 19 thirds, and 20 thirds. If we solve this out, x minus 4 thirds means our multiplier is going to be positive 4 thirds. And now we want to see what we get. If we drop the 1 down, 1 times 4 thirds is 4 thirds. Negative 19 thirds plus 4 thirds would be negative 19 plus 4 is going to be negative 15 over 3, which is the same as negative 5. Do some multiplying. Negative 4 thirds times negative 5 is negative 20 thirds. If we add that up, that's going to be a remainder 0. So our answer is 1x minus 5, or just x minus 5. So that would be the width. The width is x minus 5, and I suppose we should label this feet. X minus 5 feet is the width. All right, so you're going to try some of these out now on the practice.